and welcome to another episode of Lexx Education, the comedy science podcast where comedian me, Laura Lexx, tries to learn science from her nerdy, younger, normal brother, non-comedian Ron.
That's me! I'm Ron. Hello.
I put all your descriptors into one thing, Ron.
Oh, I contain multitudes.
You are a multi-tube. How are you, Ron?
I'm okay. I forgot to have a lunch break today, so we're recording early on this dreary day.
It is dreary. But do you know what? I take dreary over the most terrifying drive of my life last night trying to get home from Cheltenham. And the weather was so bad. I think I aquaplaned like 5 or 6 times. Just like... It was genuine roulette as to whether you were going to die at any point. It was horrifying. It's like, if we're not going to fix climate change, and I understand the hypocrisy of moaning about climate change while I'm saying my driving was affected by it. I get it. I don't have a very environmentally friendly job. But can we at least then like put in the infrastructure to deal with the results of what you're not willing to change to fix, you know?
Higher up roads.
Or roads with better drainage.
Smaller clouds.
Yeah. Let's do that thing where you fire metal into the clouds to keep the clouds away.
Like the Chinese did for the Olympics.
Yeah. I'm sure that had no knock-on effects.
Well, actually, I think it made the air in China better.
Yeah. We
Hannah Ritchie talks about this. Friend of the podcast, imaginary friend of the podcast, Hannah Ritchie, talks about how they really got their shit together because lots of people were going to China and they were like, shit, we can't have them breathing this air. You know, like when someone comes over to your house and you're like, fuck, this place is a tip. We got to clean this up.
Yeah.
China effectively did that, but with pollution.
Yeah. They've hoovered up that dog hair in the air.
It's my favourite Pink Floyd song. What?
Dog hair in the air.
The great dog, yeah.
I've nearly finished butter.
Nice. Can I have your login so I can just listen to the last half?
You have to put it on 1.5 speed, though, because she talks so slowly, and you're like, it's already a slow book. You can't read it ponderously. I tell you what, here's my thoughts, as no one's replying to me in the WhatsApp group set up to have this book
Well,
club.
but the thing is, you said no spoiler-oips in your message, and then...
But ages ago when you came to say, you said you were halfway through.
Yeah, but then I don't know if any other one else in there is, because we're in there with a bunch of fucking randos. Thanks, Meg.
Where are you up to?
Just over halfway through. I haven't read any in ages.
What's happening in the plot?
I think she's just gotten back from where the lady grew up.
Oh, yeah, okay.
But no, you're right. To reply to you now,
I'm way past there.
Your theory, I don't think is true because the sister didn't recognise that man either.
Yeah, but they said he had a mask on. But also from where I am now, no, that didn't happen. So don't worry about that theory that I had.
Yeah.
But I think that bit where she goes to the village, that is the best bit. And then it's quite good for a few chapters when she gets back from there. And then it just goes real boring again.
Oh, is that the best bit? That bit wasn't great.
No, but at least that bit had me like, ooh, what's going to happen next? It felt like there's
development.
Plot.
Yeah.
Yes, there was something we were trying to work out. There was drive. We were going somewhere. And then she sort of gets back and it kind of settles back into just like watching some people be moody.
Yeah. 2 massive dud books in a row.
Woof. Like this one was like a boring sandwich. It had a great filling and then boring bread.
I was quite gripped at the beginning, actually. For me, it was more of just a descent into dull rather than...
Yeah, but when you say you were gripped at the beginning, do you mean for like half a chapter?
No, chapter or 2. They're long chapters,
That's
though,
like
listener.
90 pages.
Yeah. But I was on holiday, which helps. I was on, I was poolside, which is always where the best reading is done.
So anyway, what we're saying is the Lexx Education Book Club does not necessarily recommend Butter by, was it Asako Yuzuki? What's her surname?
But we also don't not recommend it. It's just not for us. I don't think it's bad. I think it's just not for me.
I think somebody in the Discord had read it, actually.
It's quite. I think it's quite a zeitgeisty, trendy book.
Yeah. I think I'm just not a zeitgeisty, trendy person.
No, you like Tom Builder and his witch tits.
I did like Tom Builder and his witch tits. Like, I can't believe you stuck this one out and not Tom Builder and his witch tits, where there was shit happening every fucking page.
Yeah, but...
You'd kill for a dead wife and a new witch somewhere in the middle of Butter.
No, Butter was interesting, though.
Stop talking about these fucking tigers going around a tree. No one cares about little Babaji and his tigers.
Yeah, but we can't point to... And I didn't choose Butter either, so I'm not particularly defending it. It's my choice next. But there is...
What? When's it my choice?
After me.
Who chose Butter?
Sarah.
But she chose the first one that you all whinged about.
Yeah.
Right, she's banned from book choosing.
Yeah, she's been shit at it. It's me next, and then it'll be you.
Okay.
And then it's the long list of randos. Thanks, Meg.
So there you go. There's an impromptu session of the book club. Everybody having a good time? Ron, my tour starts this week. It's 2 days until the tour starts if you're listening to this on release day. So just get your tickets, all right? Buy people some tickets for early Christmas presents.
Get your tickets, guys. You're not fucking signing up for the Patreon, so you better be using that money for a Sunday.
It's October now. It's Cheerful Earful this month.
Yeah, buy your tickets, guys.
They put us in the big room, and we're going to look like 1 year only chumps if we sell fewer tickets for the big room than we did in the small room.
Do we know how many we've sold?
Yes, we're not going to say it out loud.
Can you WhatsApp it to me?
Yeah.
Is it more or less than my age? Oh, no.
It's going to be intimate.
Oh, no. That's less than the London Podcast Festival.
Yeah. I did say we should stay in the small room, but no one wanted to listen to me. So buy tickets for that. Right. It's episode 2 of the chemistry exam today, and it gets real snacky. So how about all these things we've asked you to spend your hard-on money on, do it before you listen to this episode.
Did you say hard-on money on? Your hard-on money.
Your hard-on money. You have rainy day savings and hard-on money. Money that you've put aside for days you have hard-on.
My boner bucks, my hard-on money.
I just said hard-on in a really long time.
Yeah, hard-on's vintage. Hard-on's funny.
You should use that next time you're proposing amour with Judith. I've got a hard-on. Do you reckon that would translate?
I think so.
I might try it.
Hard. What's hard? Schwer. I think. Schwer. Hang on, I wonder if that dildo company emailed me back. Listener, you'll find out after the episode. Laura.
Yeah.
Question 6.
I think I need a snack.
What's she getting for snacks? She's getting plain digestive and fancy Nutella.
What are you laughing about?
Your fancy Nutella.
It doesn't have palm oil in it.
That's nice. Or why didn't you just buy chocolate digestives?
We normally do, but I've been trying to
take out a bunch
feed Charlie
rather than
podcast.
rustling every time.
No, because then I'll eat a bunch, and I just want to eat one. I've been trying to feed Charlie the podcast less sugar, but not be a boring parent. So we got plain digestives, so she could have a biscuit, but it wasn't quite as luxurious as the biscuits me and Tom stuff our faces with when she's gone to bed. But we've eaten all our biscuits, so now I'm eating hers covered in chocolate spread. Okay. Judgy, do you want one?
No. think this might be the worst podcasting food either of us has ever eaten.
No, the olives. The olives is the worst. You lick each finger individually after each olive. You didn't eat a load of olives and then eat your fingers, so there was one awful finger bit. You just did it over and over again. I swear to God, those olives are the reason we are never in the podcast charts. If you hadn't eaten those olives, we'd have sold out London Podcast Festival. Gareth wouldn't have even been able to come.
And all the more reason to eat olives. We love Gareth. What a guy. Everybody pay for him to walk up them stairs. Laura, question 6. Oh, I want a snack now. You didn't even get the Maltesers.
Have a snack.
I don't want this DIY snack.
It's lovely.
Right.
There you go. Just put spread on it. Stop being so fancy.
I quite like it. Maybe I have some cheese with it. What do you mean, What do you mean,
Cheese on a digestive?
Yeah.
No.
Why not?
Yuck.
Cheese and biscuits is a very famous
Those
thing.
biscuits like crackers.
You can literally get digestives in a cracker set. Get me some cheese, you'll see, it's delicious.
Fuck off, I'm not getting you cheese.
Cheese? I'll show you. Laura, this question...
What about melted cheese on a digestive?
That sounds delicious as well.
Yuck, no.
Why not? I'd prefer cold cheese, maybe with some chutters and a grape, but...
We've got grapes, probably got cheddars.
Get me all 3!
No, I'm doing an exam.
This question... I don't know if in the middle of the exam, and to fetch your examiner's snacks. Maybe in Butler exam you do. Hey listeners, what's the weirdest exam you've ever done? Write in Lexx Education at googlemail.com. Or question 6. This question is about metals. Platinum is a metal used to make jewellery. Suggest one reason why platinum is used to make jewellery.
It's very hard and therefore doesn't scratch or wear down easily. Oh, you are giving me a real face.
Oh, just because of the biscuit.
Should I say it's very soft and therefore it's easy to make into jewellery? No, I think it's hard. Shut up.
Figure 7 shows a piece of sodium being added to water. I think figure 7 might be the most useless figure.
They've really put some effort into drawing those tongs. Like, they've got specific handles. You can tell that those are rubberised handles. I can picture them as red, you know?
Yeah. Give 2 observations that could be seen when sodium is added to water.
Farty bubbles. Was there a more official name we had for farty bubbles? Yeah, I'm going to say bubbles.
You want me to get rid of farty?
Probably. I'm sure we called them farty bubbles. Bubbles and a flame.
Okay. Final answer?
Yeah.
Copper is a transition element. Sodium is a group 1 element. What are 2 differences between copper and sodium?
Oh, fuck. Copper is a transition element. Sodium is a group 1 element. What are 2 differences between copper and sodium? Okay, my options are copper has a lower melting point. Copper is harder. Copper is less dense. Copper is less reactive. Copper is less strong. Right, I'm definitely going to go copper is less reactive. Sodium, I guess it has a melting point. I've never really talked about the melting point of group 1s. Copper is harder. Copper is less dense. Copper is less reactive. Yes. Copper is less strong. Gosh, I just don't know. Copper and sodium. I don't think I can tell the melting points from the periodic table. Copper is harder. I know copper's quite a soft metal. I don't know how that would compare to sodium. Copper is less dense. What is copper? Is there... Oh, I don't know how I could know that. Copper is less strong. That one doesn't feel right. I am going to say copper has a lower melting point, Ron. No, that doesn't make any sense. Because you could literally... No, that makes no sense. No, that makes no sense. Harder, denser, stronger.
That'll kill me.
Fuck!
Better, denser, stronger.
Copper is harder. Let's say harder, because sodium you can like scrape it, can't you? I'm going to say copper is harder.
Let's try one of these.
Oh, yeah. He's putting the chalky spread on the bicky.
And then, after this,
You can make it a sandwich.
We'll have a cheesy one together.
Ugh.
You should try it, man.
What kind of cheese?
Just nice, strong cheddar's best.
Shall I get it out the fridge to warm up?
Do you want warm cheddar?
Yeah, cheese is much better at room temperature than fridge cold. You should always get your cheese out the fridge an hour or so before you're going to eat it.
That seems crazy.
No, if you're having a cheese board, you don't want it fridge cold on.
Don't you?
No.
Alright, but what if it goes sweaty?
I think that's when the flavour comes out with the sweat.
Ugh. Harder to eat.
Yeah, it's really sticky now, covered in chocolate.
Hands feel dirty again.
Wipe them on your collar.
The metals, aluminium and copper, can be used to make pans for cooking. Table 2 shows information about the two metals. The higher the value for thermal conductivity, the better the metal conducts thermal energy. Table 2.
Okay, so we've got a table here. We've got thermal conductivity in arbitrary units. So the conductivity of aluminium is 250, copper is 400. Density of aluminium is 2.7, copper 8.9. Cost of metal per kilogram 1.5 for aluminium and 7 for copper.
Evaluate the use of pans made of aluminium and of copper.
Okay, so I'm going to start with copper pans would be more expensive than aluminium pans. Copper pans would also be heavier than... Is that true? Density in grams per centimetre cubes? Yes. Copper pans would also be heavier than aluminium pans. However, copper pans would conduct heat better than aluminium. I would have to argue, though, that the improvement in conductivity is not outweighed by how much heavier and more expensive it would be. The only copper saucepan the average cook would need would be like a small saucepan for things like hollandaise or butter. You don't need to add that last part.
That was just for me.
Yeah. It's also because copper is so reactive. You spend an age keeping them shiny and nice. The dream situation is a copper panel in the middle of your saucepan, like copper through the middle. So my Le Creuset saucepans, they have stainless steel on the outside, copper in the middle, stainless steel on the other side. So it's a little copper sandwich. So you get good conductivity, but you get the hard weariness of stainless steel on the outside.
Anything else you want to add?
No, how much of that did you put in?
I've got copper pans would be more expensive than aluminium pans. Copper pans would also be heavier than aluminium pans. However, copper pans would conduct heat better than aluminium pans. However, this would be outweighed by how much heavier and expensive they would be.
Sure, I'm happy with that. There were 4 marks, and I feel like I've given 3 pieces of information from the table and then a summary.
Okay. Question 7.
God, we're only halfway.
We have been recording for 1 hour and 13 minutes.
Jesus.
This question is about ionic compounds and electrolysis. Sodium chloride is an ionic compound. Figure 8 represents parts of the structure of sodium chloride.
Okay, so I've got a cube here, and on the top 4 corners of my cube, I've got a positive sodium ion on 2 opposite corners and a negative chlorine ion on the other 2 corners.
Complete figure 8.
Okay, so if you think of the square on the bottom as opposites, I'm going to put chlorine negative ions underneath the sodium positives and sodium positives underneath the chlorine negatives. Does that make sense to you?
Give one reason why molten sodium conducts electricity. Molten sodium chloride conducts electricity. Refer to ions in your answer.
Because molten sodium chloride has loose ions who have more energy to move and are not strictly bonded together in a rigid structure, so they can pass electrical current along.
Is that everything you want to say?
Yeah.
I need to get a charger.
I need more biscuit.
Get the cheese.
No, I don't want cheese.
It is a dark and stormy night.
It just doesn't feel much like August. It feels very September-y.
Birthday?
Yeah. Why did you ask me about my birthday?
Because if you were doing something, then maybe you'd have done something, but you said no.
Well, you should come down. I told you I had the day off.
Maybe. Table 3 shows products of the electrolysis of 2 molten ionic compounds. Told you. Gonna get some water while you chew.
You've got mine up.
Yes.
I've done like 4 of these today.
Well done.
Right. Table 3. The molten compounds we have are magnesium bromide and potassium chloride. The product at the negative electrode, I've got magnesium for magnesium bromide and then a gap for potassium chloride. The product at the positive electrode, I've got a gap for magnesium bromide and chlorine for potassium chloride. I've got to complete it. So I'm going to put bromine in the product at the positive electrode for magnesium bromide and potassium in the product at the negative electrode for potassium chloride.
So I wasn't here and I wasn't listening.
I got it right.
Alright. 2 marks. I think I heard you say it. Okay.
I pretty much did, I think.
Aluminium is extracted by electrolysis. The electrolyte is a molten mixture of aluminium oxide and cryolite. Why is a mixture used instead of pure aluminium oxide as the electrolyte?
The options are: the mixture has a lower melting point than pure aluminium oxide. The mixture has the same melting point as pure aluminium oxide. The mixture has a higher melting point than pure aluminium oxide. Aluminium is extracted by electrolysis.
What's going through your head, Laura?
Shut up.
Yeah, but this is... You've got to
but
make
I'm trying
content.
to read. You
gotta
do
make
it
content. Oh, I wonder what she's thinking about. I watched Hot Fuzz the other day. You know who's very funny in that film? Olivia Colman. Oh, the roles she's had.
Okay. I just was trying to work... Ron, I'm very tired. We've been recording for an hour and 20 minutes. I don't understand this at the best of times when we do it for 45 minutes in the middle of the day. It's midnight and we've been doing this for 3 days.
We've been doing this for so long.
I think a mixture is used because it has a lower melting point than pure aluminium oxide.
You sure?
I'm pretty sure. That would make the experiment cheaper to run and quicker.
Okay.
No? Oh, I hate this!
I'm just laughing because you called it an experiment.
What is it?
Well, they're making aluminium.
All right, then. The manufacture.
Electrolysis is like, ooh, I wonder if it'll make aluminium again. What a devious experiment. Better make it cheap. Shit, we've got all this aluminium now after all of our experiments. What should we do with it? I guess fund global industry. Electrolysis of an aqueous solution of sodium sulfate produces hydrogen and oxygen. What is the source of the hydrogen and the oxygen produced during electrolysis of aqueous sodium sulfate solution?
My options are air, sulfate ions, and water. I'm going to say water, Ron.
Talk me through it.
Because I've got hydrogen and oxygen, and water is H2O.
Water is H2O. Electrolysis of an aqueous solution of sodium sulfite produces hydrogen and oxygen again. Why is hydrogen produced instead of sodium in the electrolysis of aqueous sodium sulfate solution?
My options are hydrogen is less reactive than sodium. Hydrogen has the same reactivity as sodium. Hydrogen is more reactive than sodium. Hydrogen is more reactive than sodium because it has its single electron, which sheds easily. It's only ticking a box there. That's right though, isn't it?
How many electrons does sodium have?
Like at least 2.
Figure 9 shows the relationship between the volume of hydrogen and the volume of oxygen produced during the electrolysis. Give one conclusion that can be made about the volume of hydrogen produced compared to the volume of oxygen produced.
I've hit the point now where I can't take in what you're saying, so then I have to read the question on my own after you've read it out.
Do you want to just read it from now?
No, I want you to do some fucking work. I'm just explaining to you why I then end up having to stare at the screen for a while.
Sure.
Right, figure 9 shows the relationship. Volume of hydrogen. Okay, yeah, cool. So figure 9, we've got another graph. On the y-axis, we've got volume of oxygen produced in centimetres cubed. That's sort of going from 0 to 4. Then we've got volume of hydrogen produced in centimetres cubed. That's going from 0 to 8. The line starts at 0 on both axes and goes way up to 4 on the top and 8 on the other in a steady, continuous straight line.
What's your conclusions about the volume of hydrogen produced compared to the volume of oxygen produced?
Hydrogen is produced at a rate of 2 to 1 of oxygen.
Why do you think that would be?
Because there's 2 hydrogen atoms to 1 oxygen atom in water.
Sounds about right to me.
Pew pew! Killing it.
I don't feel like yesterday's exam had these pithy introductions for every single question. Question 8. This question is about displacement reactions. Iron is extracted from iron oxide by a displacement reaction with carbon. Balance the equation.
All right. Come on, Laura. We believe in you. Right, I've got Fe2O3 plus 3C. They do arrows instead of equals, but I'm going to say equals blank Fe plus blank CO. So I've got 3 O's over here, which means that has to be at least 3 CO's over there. That also gives me 3 there. And I've got Fe2 there, which means I need 2 single Fe. Oh, that was actually surprisingly easy. Ron, I believe it is 2 Fe plus 3 Co.
Okay. Iron oxide is reduced in this reaction. How does the equation show that iron oxide is reduced?
Well, there isn't any iron oxide. What? Because there isn't any iron oxide? I need help here, Ron. Can you help me? There isn't any iron oxide in the result of the equation.
What if I said the words oxidation and reduction?
The iron oxide has been reduced to just iron.
What does an oxidation reaction do?
Adds oxygen.
What does a reduction
Removes oxygen.
No.
Removes iron.
No.
I don't know.
No, you don't know those processes, so you're not going to get it.
Okay, it doesn't count as a help then because it didn't help.
That does count as a help.
No, because you didn't help me.
No, you just still don't get it even with the help.
Write in.
What? Because there isn't any iron oxide.
27 Heartbreak Hotel Brussels and let us know if that counts as a help or not.
What do you want to write as your answer?
Due to reduction in iron oxide, there has been an oxidization of the carbon and reduction of the iron oxide to pure iron. Reduced. Oxidized. Snort.
So, the question was...
No, don't read it back to me. I don't want
Iron
to know.
oxide is reduced in this reaction.
I'm not interested.
How does the equation show that iron oxide is reduced? You've said, due to reduction in iron oxide, there has been an oxidation of the carbon and a reduction of the iron oxide to pure iron reduced to base.
I don't think I said base.
I didn't catch that last word that you said. What was it?
It was the right answer, but you didn't. You bad invigilator.
Invigilators don't usually collect the answers like this. 8.3. Calculate the relative formula mass of Fe2O3.
Okay, so I've got Fe2O3. Relative atomic mass is O16.
Oh my God, there's so much left.
Fe56. So I'm looking at 112 of Fe and 1630, 48 of O2. So we're looking at 150. MR equals 150, Ron.
Okay. Whew. Copper oxide reacts with hydrogen to produce copper. That's the equation. Calculate the percentage atom economy for obtaining copper from this reaction.
What the hell? Calculate the percentage atom economy?
There is an equation for that immediately underneath there.
Oh, okay. Use the equation percentage atom economy equals AR of Cu. Oh, fucking hell. Oh, they should have started with this when I was fresh on the brain train. Okay, so AR of Cu, 63.5 divided by MR of H2, which is 2, plus MR of CuO, which is 79.5, so that's 81.5. So 63.5 divided by 81.5 multiplied by 100 according to this formula, 77.914, Ron. 77.914%. I don't remember covering this.
Okay.
Am I getting the maths ones right?
In some ways. A student investigated the reactivity of 4 different metals, A, B, C, and D. The student added each metal to aqueous solution of each of the metal sulfates, observed whether a reaction took place. Give one observation that would show a reaction took place.
Gas escaping. Gaseous bubbles, Ron.
Gaseous bubbles.
Yeah.
It's my favourite Harry Potter character. Table 4 shows the results.
Oh, God. This is going to be a hard table to make fun.
Which...
Well, yeah, we're moving on.
Basically, put the metals in order of reactivity.
Okay, so...
I don't think we need to describe the table too much.
Okay, so D-sulfate has a cross in the box where it's been tested against A, B, C, and D. So we're going to say... No, wait a minute, I'm supposed to be doing this the other way. Metal C has not reacted with any of the sulfates. So C must be the least reactive one. Then A has only reacted with 1 sulfate, so we'll put that in position 2. B has reacted with 2 of the sulfates, and D with 3 of them.
Reason? I
kind of did that as I was going along, didn't I? Discord's popping.
Question 9, Laura.
Yeah.
This one doesn't tell you what this question's about.
Whoa, we're into the unknown.
Discoveries in chemistry led to a better understanding of atomic structure. Atoms were originally thought to be tiny spheres that could not be divided. The plum pudding model of the atom was then developed. Figure 10 represents the plum pudding model.
I'm so happy this has come up.
Describe the plum pudding, Laura.
So the electrons are the plums in the atomic pudding, meaning that the atom...
One of my favourite girl bands.
The atom is a dense object with the atoms sitting in the body of the atom. The electrons sitting in the body of the atom, surrounded by matter.
Do you want me to read that back?
Yeah.
The electrons are the plums in the atomic pudding. The atom is a dense object with the electrons sitting in the body of the atom surrounded by matter.
Yeah, I think that's an okay description. Let's put negative and positive. So the negative electrons sitting in the positive atomic matter, okay. aka pastry.
So, just to editorialise you there a bit, the negative electrons sitting in the body of the atom surrounded by positive matter.
Yes.
Okay. Atoms contain electrons, neutrons and protons. Write these 3 particles in order of their discovery.
Ooh. Don't know.
Earliest to latest, please.
I'm gonna say earliest was electrons, because they sort of come up in the reactivity, don't they? So they're probably the most easily noticeable. And then we're gonna say protons, because we knew about isotopes and stuff. And then we're gonna say neutrons, because let's say they're harder to gauge.
Very few atoms of the element tennessine have ever been identified. The atomic number of tennessine is 117. Predict the number of outer shell electrons in an atom of tennessine. Give one reason for your answer. Use the periodic table.
Surely it's tennessine, and it was discovered in Tennessee, I would expect. I'm going to say it's
tennessine.
Got 1, 2, 3, 4, 5, 6. It's got 7 rings, Ron, and I'm going to say that because it is on the 7th row of the periodic table. No?
Number of outer shell electrons.
Oh! Wait, I thought you said about rings. Okay, never mind.
I didn't say anything.
God. Right, so I think it's got 7 rings to rule them all. You can have 2 rings in your... Oh, God. No, I think it's got 7 in its outer shell. Don't I? Do I? Do I? Wait, no I don't. So, has it got 32? No, that doesn't make any sense. Or does it? No, I think it does. 32? No. Those are much fuller. Oh God, my brain! 31.
And why?
So my logic here is that it's in group 7. Group 0 next to it is the noble gases that are very unreactive because their outer rings are full. So next to it, it's got oganes on. That's got 100 and... No, wait, I'm doing this all wrong anyway. Oh, fuck, I just don't know. Because that's protons, isn't it? It's not even electrons. But wait, what did it say? Atomic number is 117. Wait, atomic number, and that's the atomic mass. So 294 minus 117, 8777, 177. It's got 117 protons. I can't remember how to work out the fucking number of electrons. The atomic mass. Oh, 234. So has it got 60 electrons?
You're overcooking this.
Yeah, I don't know what I'm doing.
You were closer with your first answer. You can tell just by looking at the table. You don't have to do any maths.
Can you?
Yeah. That's a free help, because we've been doing this for an hour and 40 minutes. It is 9 o'clock.
It's 7, Ron. Just put 7 down.
I can put 7, but why?
Because it's in group 7.
2 marks, there you go. It's that simple. It's that fucking simple, Laura.
God. I'm so tired.
Tennessine was...
Tennessine! Stop calling it Tennessine!
Was first identified by a small group of scientists in 2010. Suggests one reason why Tennessine was not accepted as a new element by other scientists until 2015. You must be faster.
Because...
And funnier while we do this.
Because finding it once isn't enough. You have to prove it. They needed more evidence. They needed more examples. What's like a sciencey way of saying? What's the sciencey way of saying that? Do you know what I mean? Like, you can't just go, oh, we found it once. What did you just... That's pistachio gobs from yesterday.
I want snacks.
Well, help me then, and then this will be over.
I've given you so many helps.
You stop clapping together like you got hooves. I'm going to say they had to get further evidence.
Yep.
Sure.
Okay. The discovery of isotopes explained why some relative atomic masses are not whole numbers. Element R has 2 isotopes. Table 5 shows the mass numbers and percentage abundance of the isotopes of element R. Calculate the relative atomic mass of element R. Give your answer to 1 decimal place.
Oh, God. Oh, my brain is in panic mode. Table 5 shows the mass numbers and percentage abundances of the isotopes of element R. Stop stroking things. Calculate the relative atomic mass of element R. Okay, so... Fuck. Oh, shitting tits. Right, so 7.6% of it is 6.
Oh, nice. The page after this is just a free page. That's getting us towards the end.
Right, let's just bash this out. 6 times 7.6 equals, and then 92.4 times 7 equals. Let's do those as sums. Why are you laughing? Ron?
It's just funny.
Why?
It's just, the podcast is funny. Funny podcast, isn't it?
No, that's not why you're laughing. I'm not thick. Except about science. 273.6. And then we're going to do 92.4 times 7 equals 6. Like, if you're listening to this, it's the 4th week of exams. I want you to know this has just been 2 evenings for us.
In a row.
And it's too much. 273. Oh, fuck. I pressed the wrong button. 273.6 add 646.8 equals 920.4. Then I'm going to divide that by 100 for fun reasons. 9.2 on final answer. Look, I can either speed up, or I can beg for help, or I can get it right. What do you want me to do? Wait, that can't be right. Hang on. Hang on, Ron.
The average mass of things that are 6 or 7 big is 9.2.
Okay, hang on. Right, I've gone wrong in my numbers there. 45.6. The calculator let me down. 0.8 equals 692.4. I'm going to divide that. 6.9, Ron. 6.9, final answer. Yeah, blanky blanks, page 30.
Here we go. Question 10, Laura. What does it say this question's about?
Temperature changes.
Yippee.
It's temperature changes.
A student investigated the change in temperature of a solution where different masses of ammonium nitrate were dissolved in water. The method used is such. 1. Measure 200 centimetres
Read
cubed.
it quick, Ron, because I can't hear it anyway.
200 centimetres of water into a polystyrene cup. Measure the temperature of the water. Add 4 grams of ammonium nitrate into the water. Stir the solution until all the ammonium nitrate has dissolved. Measure the lowest temperature reached by the solution. Repeat.
Do you know, I
5
actually
times.
followed that better with you talking at that speed.
Yikes, you bad brain.
That's great, Ron.
Give the independent variable and the dependent variable in this investigation.
The independent variable is the... No, let's start the... Wait. The independent variable is the mass of ammonium nitrate. The dependent variable is the 200 centimetres cubed of water.
The volume of the water.
Yes. Is that right? Yeah, that's the thing that's always stayed the same, and the thing that's changing is the mass of ammonium nitrate. No, wait. Independent variable is the dependent variable, Ron, is the temperature of the solution. Temperature of the solution. Final answer.
Okay.
It's not control and variable. It's, yeah.
Then we've got a table of results. It's a graph, so we can skip that one. We're not doing graphs.
We have done some graphs. Oh, no,
No,
we're not drawing a graph.
Drawing graphs.
No, skip a Rooney.
Which means we can't do that. How do the results show that the dissolving nitrate is endothermic?
Well, I don't know. I haven't done the graph.
We'll skip that one too. Oh my god, I'm so happy.
Endothermic means they're taking in heat energy.
And we can tell that from...
The temperature of the water dropping.
Yeah, the more...
Yes.
Yeah. The student repeated the experiment 3 more times. The student recorded the mean lowest temperature of the solution for 8 grams of ammonium nitrate as 16.5, plus or minus 0.3. Explain why the student included plus or minus 0.3 after the mean lowest temperature.
Because all of the test results fell within that bracket. The lowest it was 16.2 according to Table 7, and the highest was 16.8. So it's an average of 16.5, and none of the results went beyond the range of plus or minus 0.3 degrees C. I'm going to go let the dog out while I'm killing it.
What type of error is shown by the results of Table 7?
Oh no. Right, our options are random error, systematic error, zero error. Error? I don't know about an error. I'm going to say zero error. I trust the student.
Okay.
Oh no, this one's got 6 marks, Ron.
This question is about making a soluble
Oh,
salt.
fuck, I feel like soluble salt's something we've talked about a lot.
Plan a method to make pure dry crystals of zinc chloride from zinc carbonate and a dilute acid.
I'm calling in a help here, Ron.
I've already given you all the helps.
No.
I have.
You haven't.
I've given you so many
One
helps.
of them I was unconscious under the sea for, so it doesn't count.
That's not my fault. Come on, Laura, take us home.
I don't know, Ron. It's not home. There's still 3 more pages.
No, we're done.
What is it?
Yeah, this is the last page of questions. See, it says end of questions at the end
Oh,
of this
yeah.
page.
Additional page if required. Oh, I just don't even know where to start, Ron. Make pure dry crystals of zinc chloride from zinc carbonate and a dilute acid. Not the foggiest fog. A soluble salt. Okay, here's my method. I'm going to I'm going to dissolve some. Fucking don't know. Just dissolve some zinc chloride in some water, and then I'm gonna fucking heat it up. Should I heat it up or put an electrode in it? I don't know. No, I tell you what. Instead of heating it up, just stick an cathode and an anode in it. Let's do that one. And then make bubbles. Positive electrons.
Right, okay, hang on. I'm going to stop you there. Read the question again. Because you've been asked to make pure crystals of zinc chloride from zinc carbonate and a dilute acid. And what you've told me so far is to dissolve some zinc chloride in some water and then stick a cathode and an anode in it. You're starting with the thing you're being asked to make.
I can't do this anymore. Oh my god, this is dreadful.
Yeah. Laura, if we go for another 9 minutes, we've been doing this for 2 hours. Why are we doing exams for fun?
Too long. All right then.
Come on.
Put the zinc carbonate in a dilute acid. Oh, I'm not going to get 6 marks, Ron.
What dilute acid?
I don't know. Something with chlorine in it. Let's go hydrochloric acid.
Thank you.
And then I'm going to get water and zinc chloride. I don't know how though. How am I going to separate them? I'm going to heat them up. Shall I heat them up or put an electrode in? catalyst. Shall I put a catalyst in? I'm going to put a cathode and an anode in. No, I'm going to heat them up.
Heating them up?
I don't know. What shall I do? I'm going to heat them up. I don't know what to do. I don't even want any zinc chloride. I'm going to heat them up because I've got to get it dry. So I've got to get rid of the water. I'm going to heat them up, boil it until the water goes away. And boil it, and then I'm going to have zinc chloride. I'm finished. I don't care anymore.
Put the zinc carbonate in hydrochloric acid, and then I'm going to get water and zinc chloride. I'm going to heat them up. Boil it until the water goes away.
Next question.
Name 2 other substances that can be reacted with a dilute acid to make zinc chloride. Do not refer to zinc carbonate in your answer.
What?
Laura, come on. Laura, we could stop. We could stop so soon if you stopped fucking around on your phone.
I'm doing socials. Name 2 other substances that can be reacted with a dilute acid to make zinc chloride. Fucking don't know. Zinc manganese. It's really all come apart at the end. It's fucking tragic.
You want me to write down zinc manganese?
I don't know. 2 other substances can be reacted with a dilute acid. Do not refer to zinc carbonate. Okay.
Do you want me to write zinc manganese?
No! Chlorine. Can I just say chlorine?
So if you put chlorine in a dilute acid, you're going to get zinc chloride.
No.
Is that what you're saying?
Are there other acids that have chlorine in them? Zinc manganese. 2 other substances.
We've got zinc manganese so far and chlorine.
Boron. Hang on, let me look at the periodic table for inspiration. Zincatin? Is this what?
Zincatin?
I don't know. I don't care either. Zinc. I don't even really understand the question. 2 other substances can be reacted with a dilute acid to make zinc chloride. I don't know. If you... where is the chlorine in the acid? Ron? Sulfur dioxide?
Just tell me a thing and write it down.
Acid? Tell me an acid for an example.
Phosphoric acid? Does that help?
No.
No, it doesn't help. So why the fuck did you ask for that?
Because you were laughing at zinc manganese. I don't know what else I'm supposed to say.
What do you want me to write down?
Zinc manganese.
I've got zinc manganese. What else?
And nitrochlorine. Nitrocarbons?
Nitrocarbons?
It's got to have chlorine, hasn't it? Chloroxide?
Chloroxide.
Yeah. I don't know.
Alright, exam over.
Fucking hell.
How about adding fucking just zinc?
You said I couldn't just put zinc in.
No, I didn't.
I said zinc and you said, oh, if I got just zinc in, I'm going to get zinc chloride, am I?
In the first... No, that's not what happened.
Listen to the tape back and that's what fucking happened.
In the first question, you tried to start your zinc chloride method with zinc chloride. I didn't say you couldn't just add zinc. Exam over. We've been doing this for 2 fucking hours.
See, how the fuck are we going to do higher tier?
It's going to take a long time.
Did they?
No, they have not emailed me back.
So yeah, listener, listen up. We don't want to say that we save you from a lot of adverts that you don't want to listen to, but we have been approached about advertising, what was it called? Ultra Orgasmic.
Ultra Orgasmic, paid collaboration opportunity with Ultra Orgasmic. Hi Laura, we love your content and we'd like to collaborate with you. Please share your rates with us. We'd also like to send you a gift to unbox and review. Additionally, we're interested in exploring a long-term partnership. Looking forward to hearing from you. I've gone back and I've said, hi, Harry, thanks for getting in touch. Our rates depending on exactly what you'd need from us. So maybe you could send over some suggestions of content that you'd like to create. Are you hoping to get both hosts involved in this promotion?
Like,
best regards.
Why would you reach out to a brother-sister GCSE podcast about your orgasm products? But hey, if you guys don't join the Patreon, we're going to have to start having orgasms near each other. So probably best we don't go down that route because it'll ruin Christmases for a lot of years to come for our family.
Yeah, not keen.
Not keen at all. Wouldn't even be keen, to be honest, if I wasn't doing a podcast with my younger brother. I don't think an unboxing of orgasm stuff is generally something that's like huge for my brand.
No. Do they think you're a sex worker?
Mabes.
It's just the long-term partnership, because if I wasn't doing this with my sister, I'd have no problem shilling marital aids on a podcast. I think everyone should have good sex, but it's the long-term partnership bit. Also the unbox and review.
Yeah, it's not that I have, like, sex shame. It's just that I don't think I'm a particularly, like, sexy behaving person. I think if you had to list the attributes, like the characteristics that I use and exploit in my work, childish comes way higher than sexy. I don't talk about sex loads, and when I do, it's generally quite ridiculous. I don't know if anybody's coming to me for sex.
No, and I mean, in my line of work, I spend 4 hours a day making a pitch deck for a new professional services stream that I want to set up at work. So it's hardly dildos galore for me either.
But look, we're going to have to do it if you don't join the Patreon or come to Cheerful Earful, all right? So maybe Cheerful Earful is when we'll do the unboxing. We'll get the products and we'll unbox them live just before the song.
Have you written that song
No,
yet?
You're writing it.
How about this? Let's say we're not doing the song, and we'll see if we sell a few more tickets now that people aren't avoiding that.
I think that the unspecified number of people that have bought a ticket are only coming for the song.
I think the unspecified number of people that have bought a ticket are exactly who we think they were, and they bought those tickets before we said anything about it.
Yeah, that's what I love about what we're doing, is that even if it is only that unspecified number, we're going to have a fucking wicked afternoon.
Yeah.
Girlfriend of the podcast, Judith's coming, so you could all come.
Yeah, but she's not bought a ticket.
With your thoughts about the year off.
What, me?
No, all the listeners.
Okay.
We could put Judith on trial for breaking Ron's heart.
Oh, yeah. Me and Judith are going to go see Pappy's afterwards. We could do the Beef Brothers and just be like, why did you break up with me?
Okay, so we're going to see our show, and then we're all going to go to Pappy's together. Whatever Pappy's have planned, we're going to railroad over it and go, Lexx Ed special. Judith, what the fuck?
Yeah.
Hi, Judith's mom. By the way, she listens. Bum, ba-rum. Dum, 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 dum. Who are we thanking today, Ron?
Nobody.
We're thanking nobody. Nobody is in charge of keeping Ron and Judith's relationship together. You really biffed it for about a year and a bit in the middle there, but for the years before and hopefully for the years ahead, you're going to do a cracking job. Thank you, nobody.
We're dangerously low of patrons to thank in the register.
Oh, fuck. It's because we make a shit weird podcast mainly for ourselves, and I don't care, Ron.
No.
I love it.
Class dismissed. No, pencils down. Pencils down.